Hey, hello. Today I'm going to go very deep into the heart of synthesis. I'm going to show you the custom oscillator that I did for this Korg Nu Tekt NTS-1. And we're going to get pretty nerdy pretty quickly. Alright, so the Korg digital Nu Tekt NTS-1 is this little pocket digital synth, and it comes with your like traditional sawtooth triangle wave oscillator, square wave. It has a filter, of course, an envelope. You have ADSR, attack and hold, just attack and decay. This is a loop envelope, very nice. And you have effects like you have modulation, chorus, very nice. A delay, it's actually right. You have several types of delay. Yeah, it's pretty neat. And you have even reverb. You have some reverb on this shit. Isn't that great? Alright, so what I'm actually interested in is not those onboard stuff. What I'm interested in is the ability to add custom oscillators and custom effects. So if you check it out here on the oscillator, I have a bunch of other oscillators that I loaded from the internet. And actually, you can easily write your own. Okay, so what they give you is the log SDK, which actually includes everything you need to create your own oscillator. It's actually the same for the Minilog, the Prolog, and the NTS-1. So I'm not going to delve too deep into the code, but basically all you need is to fill up some functions. You have this init function, cycle, note on, note off. You don't even need that really. And parameter is for responding to parameter changes.
Keep in mind, most people don't know about how to program in C++.
Oh yeah. So the oscillator that I did is called the MUSC oscillator, multiple oscillator. It actually includes 2 oscillators, and each oscillator has its phase, the type. So the type can actually be sine, sawtooth, parabola. Wait a minute, what's parabola? You know, I was looking at the documentation on their website, and I saw this function here, parabolic wave lookup, and then I thought, what's a parabolic wave anyway? So I looked it up, and I found this website by this guy, Guillaume Pelletier, and he's talking about mountains and how you only need 2 points to actually draw a parabola. It's actually very interesting. And he's talking about the difference between a parabolic wave, which looks like that, and a triangle wave. Okay, so this is how a parabolic wave sounds. Interesting, isn't it? It's very triangle-y. It has a bit more like harshness to it. Anyway, so this is my my oscillator, the MUSC. What a horrible name, you will say. I agree, that's a horrible name. But anyway, so you can set the type of each oscillator. So let's just have sine waves. So one is sine, and then you can adjust the interval between the 2 oscillator. So let's just here. And you also have fine interval, which you can hear like a phase shift going on. And okay, let's do something else. Now I'm going to set oscillator 2 to be a square wave. Okay, so square is 4. You have to look at the thing. And I'm going to set the pulse width of oscillator 2 to 50, so like, yeah, 50 is good. And what's really neat is that, so you have an onboard LFO. If you hold oscillator, you can see that you have an LFO. And you have P and S value. So P is the pitch modulation. So if I set the pitch modulation, you will hear it. Okay, that's not what we want. But the S value will actually modify, because I took this parameter in my code and I modulated the pulse width based on that thing. So let's hear it. Can you hear it? Yeah, that's... yeah, pulse width modulation. Hey, can you hear that, Nick Bat? Little reference there. Okay, I know what you're thinking. This is not a multi-oscillator, it's just a dual oscillator. You just have 2 oscillators. So what I'm going to do is actually I'm going to make a second custom oscillator, but this time I'm going to use a number of sine waves, and this number I'd like it to be a parameter, so you can decide how many sine waves you want, like up to 5 say, and you can actually tweak the interval between each of them. So we're going to make a real additive synthesis engine. So I just made a copy, and I have this new msyn oscillator here. Okay, so let's just start by declaring a structure. So let's just declare a structure that's called syn-osc, another weird name. So like that with a type def. And this, I mean, each oscillator would be a sine, so we don't have a type, but we do have a phase. And we do have an interval. For the interval, I will use this 16-bit integer because it's what we get from the parameters. Alright, so so let's just try it like that. So I have my thing, and here I will actually declare an array. That would be all my waves. Of course, it's statically initialized. Alright, so we can probably have a for loop to you know what, yeah, no, and be max voices like that. Okay, and this would be it, and we go to max voices, and then we initialize each voice. So waves I, we initialize each phase to be 0, and we initialize each interval to be 0. Alright, so the initialization has been done. Okay, so now let's have a look at the, I mean, they give you a bunch of little code templates for, like, you have a sine thing, so let's just look at what they give you. So naive naive sine. Okay, we'll go for the naive approach, I guess. I like the naive approach. So what they give you is so what's important here, let's not be distracted, is that bit. Okay, so like when we get here, we don't need to need that, it doesn't really matter, because this is actually, this bit of code is calculating the increment. So because yeah, at each cycle there will be an increment of the phase. Okay, so a sine wave can be actually represented as an angle, so that's the phase we're talking about, and we have to work out the increment each time, and of course the increment would be a sin function. Here what they're doing is basically soft clipping the signal, and it might be why, you know, the sine wave was sounding a bit like a triangle wave, because we were doing some soft clipping of the wave, and then we just increment the phase. That's fine. Okay, so that and that we also do because we need to bound the phase again. So I'm just going to copy that. I'm just going to put it here. So now I don't care about my drive. So this is the sin function. So let's have a float p, which is my so waves 0. Then we'll have to do a loop, but for now we're just trying with one that phase. Okay, this is my phase, and then this is, I mean, the phase should be p. Okay, yeah, like that. And then when we're done, we just do phase equals p, like that. So okay, so let's just try to compile it. Here I have my MSys terminal. I'm just typing make. Okay, he's not happy. Why is he not happy? Because this is phase increment. It's not W0. Of course, so this is phase increment. Okay, let's try it again. Okay, nice. So I'm using this digital librarian thing from Korg to see all the custom oscillators that I have on my NTS-1. Okay, let's just try to load it. What? Could not parse manifest data. Ah, maybe it's because of trailing comma? Jesus Christ, I don't know. Oh yeah, that was it. Okay. Okay, so now let's check it out. I have it here, msyn. Do I hear anything? Yes? Yes! First try. Brilliant. Okay. So now what we need to do, so we have one wave, that's fine. I'm going to go and make all the other sound. So that means that actually I have to have its same thing. And then we'll mute them according to how many voices you want. Okay, so I'm going to put all of that shit in there. And actually I need to do that here. There, all of this I need to be doing like there. Okay. So have my phase increment, and it's actually now per voice, and I have to worry about, and here it's now I. No, it's now I. Okay. Okay, so now what we need to do is we need to add the interval to the pitch. So what I can do is I can just do waves at I interval. Okay. Now I add the interval of this specific wave to my phase increment. Okay, so now I'm going to have a switch case for all the parameters. So if it's 1, then it would be the number. So we're going to have to worry about muting all voices after X. And here, if it's that, so if it's a second parameter, it would be the fine interval. Oh, what did I do? Oh, yeah, okay. So this is actually setting all intervals, and this is setting all fine intervals. Okay, so let's just worry about this for now. So when we are setting the interval, we need to actually go to every wave. So once again, we just iterate, and we need to set the interval for each wave. So this interval equals, the interval is actually straight up the value here. Okay. That's not a to do anymore. Alright, let's try it. Okay. And what if I change now the interval? So I have the interval. Okay, it doesn't work. So as soon as I change the interval, it doesn't work. Oh, I just realized I'm really stupid, because this operator takes priority. Doesn't take priority, I think. So this is going to be like we're going to bit shift by 8 plus the interval, which is not what we want, of course. It's not what we want. We want to first get the pitch and then add the interval. Okay. So now let's. Okay, so let's see. Let's load it again. Now let's change the interval. And that's normal, because we're changing all the intervals at the same time. So what we should do now is think of a way to move all the intervals differently, because now they're all like, all waves are moving in, like when I change the interval, all waves are moving like that. But no, I don't want to move like that. I want the first wave to stay here and then the other to go like that. That's what I want. Okay, I know what I'm doing wrong. It just goes to show how much I suck at synthesis. I mean, what I'm doing here is basically I'm setting all the samples for this one oscillator, but I'm never mixing them. So I'm doing it wrong, actually. I should actually do the opposite. I mean, I should do this loop inside this one. Yeah, so this signal here, I'll have to put it there. So it's 0. And then like mix, I would call it mix signal, okay? And then I have my mix signal. And then instead of doing this, I just add my signal to my mix signal. Okay, now we have another problem, is that it's going to clip super fast. So we'll have to kind of say, okay, my signal, I just times maybe 0.2, like, because we have 5 oscillator. I'll just change it later. So basically when we're here, and this is actually the mix signal that we want. Okay, so it's the signal with all the signals that we want. Okay, and now this can work. Okay, make shit, it's plus equals and not equals plus make fuck you. Fuck you. What's that again? Why was not declared? Yes, of course it wasn't declared. It's it should be there. Okay. It's because I'm really bad at programming. Okay. What's that? Plus equals. It doesn't. What assignment read only mixed signal? Why is it? Oh yeah. I told you guys I really suck at programming. Okay, so now did it work? Ooh, interesting. Yeah. So now. And now it's actually doing something. I like it. Just changed it. Okay, so now, so I need to do times I times I minus 1. What does it do if I do that? Compile, load. Okay. Now, what if I change the interval here now? Okay, we don't even need -1 actually, and it would be actually more like +1 or whatever, but because it's fine if the interval of the first oscillator is 0. It's totally okay. So I made a quick pure data patch to check a bit what's going on here. So this is a bit like we're adding, and actually like this I don't even need to actually do any multiplication. What I could do is just having like an int that would be like the interval value starts at 0, and I would just set it here, and each time we just increment it with the value, which is actually the parameter value. Okay, so we increment it with the parameter value. So that's the same, and that's a bit what I did on this pure data patch that I created, just to understand a bit more what's going on. So we're adding the previous value each time, and we're adding the interval to that previous value. So what's going on here? So okay, I think it's not that bad, because you can see that the interval is actually, because we're in MIDI, because we're in semitones, the interval is actually the same for every note. This is the advantage of working in semitones and not in frequency. So the advantage of working in semitones is that your interval would be always the same, regardless of where you are on the keyboard. So if I add 2 semitones and I have an interval of 2 semitones in here, well, it would be the same if I were here. I could just add 2 semitones and 2 semitones. Okay, so what we still need to do is adding the fine interval in here and let's not do the same mistake twice. Like that, and do waves I fine interval. Okay, so now let's just change the interval to 2. So 2 should be a chord like this, and I think that's what we're hearing here. Yeah, and 3 should be a chord like this, and that's what we're hearing, I guess. Yes. Okay, now the fine interval here. Nice. Okay, what? I can... Why are we switching a note here? I guess this is how this pitch wheel thing is supposed to work. Yeah. Isn't that the most horrible sound you ever heard? I think it is. I think it's definitely the most horrible sound you ever heard. Yeah, I think I'm going to end this video here because, I mean, it can never stop, really. Well, we can dive forever into additive synthesis. And I think we agree that this is shit for now. But you get the point. I mean, I was supposed to do this 2 minutes video, and I'm still here. So I need to go outside, guys. And I think you get the point. I hope it gave you some ideas. And really, I mean, this is a great piece of synth, and I advise to buy it. All right, guys. Cheers.